This video is all about finding the mean absolute deviation. So before we get started, you have to know the meanings of 4 words, and the first word being mean. So what does the mean mean? Well, it's just the average. It means taking the sum of all of your data values and dividing it by the number of data values. Deviation is the difference between a data value in a set and the mean of a set. So how much it deviates. Absolute value is just the distance of any value on a number line from 0. So even if it's a negative number, it's still going to be positive when we take the absolute value of it because, for example, -7 is just 7 spaces away from 0. And variability is just referring to the spread of the data, how clustered together the values are, or how spread out they are. So if there's a high variability, then your data is very spread out. But a low variability would mean that your data is very clustered together. Let's take a look at these 2 dot plots. On the one on the left, you can see that the data is very clustered together, hence low variability. And on the second one to the right, you see the data is very spread out, hence showing a high variability. Okay, so now we're ready to get started. So here are my data values: 92, 83, 88, 94, 91, 85, 89, and 90. There are 8 data values. Step 1 to finding the mean absolute deviation is to just add these numbers up and divide them by however many numbers are in that data set. And that, again, happens to be 8. So for step 1, I added up all of those numbers, and my sum came to 712. Next step was to take 712 and divide it by 8, and I got 89. So 89 is my average for all these numbers in the data set. Again, that's just step 1, finding the plain old average as you already learned how to do. Now for step 2. I'm going to look at every single one of those numbers in my data set again: 92, 83, 88, 94, 91, 85, 89, and 90, and I'm going to subtract from each one the mean, which was 89. So 92 minus 89, 83 minus 89, 88 minus 89, 94 minus 89, 91 minus 89, 85 minus 89, 89 minus 89, and 90 minus 89. Now you might be wondering what happens when we subtract some of these numbers and we get a negative value. Well, you don't have to worry because this is finding the mean absolute deviation. So technically, we're going to take the absolute value of each one of these differences, and that will end up being positive. I've left the absolute value bars around the number so that you can see that I'm actually now going to just take the absolute value of each of those numbers. So the absolute value of any positive number stays positive, and that is 3. The absolute value of -6 would be 6, because again, it's 6 units away from 0. The absolute value of -1 is 1. The absolute value of 5 is 5. 2 is 2. -4 is 4. 0 stays 0. And 1 is 1. And for the kids who understand this, you can certainly bypass that step. So now I have to add up all of these numbers: 3, 6, 1, 5, 2, 4, 0, and 1, and find the average of these new numbers. So technically, it's like I'm finding the average of the absolute values. And we must include 0 when averaging because 0 is actually part of my data set. So please don't forget that. So now on to step 3. So I've added up those absolute values and my sum is 22. Now I take that 22 and divide it again by the number of data values, which is 8. And I get 2 75/100ths. So now what does that number actually mean? Well, 2 75/100ths tells me that the average distance between each one of these data values and my mean, which was 89, is 2 75/100. This is a very small mean absolute deviation. And because it's small, it's telling me that 89 is a good representation for all the values within my data set. Because the mean absolute deviation is small, then I know that 89, again, is a good representation of all of my scores in the data set. So again, if we were pretending that all of these values maybe were test scores, and I always go back to test scores simply because it's something that you can relate to, right? Then we would be saying that 89 pretty much represents all of the scores in my data set, since again, that MAD, mean absolute deviation, is small. And as you can also guess, that would mean that these numbers are pretty clustered together. Okay, kids, I hope that this video was helpful.